Hello and welcome. This is Anil Limboo, student of Sikkim Government College, Namchi, and this is my PPT presentation on Kirchhoff's law for sessional bay examinations, Department of Physics. So here are my credentials. So my roll number is 21NS0172, and I'm a student of first year, second semester. So yeah, moving on. This is the content of my topic. So these are the topics that I'll be covering. So the first one is introduction, Kirchhoff's first law or Kirchhoff's current law, Kirchhoff's second law or Kirchhoff's voltage law, procedure to solve the problems, advantages of Kirchhoff's law, limitations of Kirchhoff's law, applications and conclusions. So yeah, moving on. So this is the introduction part. So a German scientist named Gustav Kirchhoff developed a pair of laws that deal with the conservation of current and energy within electrical circuits. So, in the year 1845, a German scientist named Gustav Kirchhoff, um, he developed these two laws, famously known laws, which we study in our 12th standard, which we are introduced to in our 12th standard, and which we study in graduation periods too. So these are the two famous laws, that are the Kirchhoff's voltage and current laws. So basically these laws were created to solve or to to calculate the values of components like resistance and voltages in complex network systems. So there are normal circuits, so we can easily find the values of normal circuits, but when it comes to circuits with complex structures or a complex system like or circuit consisting of nodes and mesh currents and all sort of things. So to solve those type of circuits, it would really be hard for us to only use formulas, simple formulas to calculate such problems. So to overcome that, the scientist Kirchhoff, he developed a pair of laws, that are the Kirchhoff's voltage and current laws, to calculate the values of components much easier in such kind of complex circuits. So which will be further studied. So this is a normal typical electric circuit which we have been learning or studying from our lower standards. So this is a circuit consisting of a switch, a simple resistance, and a voltage or cell, and obviously there is a current flowing. Okay, also in such kind of circuits, it's very easy to find out the find out the resistance. We can simply use the Ohm's law. Okay, V equals to I, V equals to IR, to find the resistance or even the voltage in such simple circuits. But when it comes to complex circuits, which we will be which I'll be telling you for in the futures in the further slide, it's very hard to solve by simply using formulas like Ohm's law and all. So for those to tackle those kind of questions and solving digging like finding out the value of the components in such type of circuits, we use this Kirchhoff's laws. For the moving on. So the first one is the Kirchhoff's first law or Kirchhoff's current law. So basically there are two laws of Kirchhoff's. So first one is the current law. It is also called as the junction rule. So according to Kirchhoff's current law, the total current entering a junction or a node is equal to the current leaving the node as no charges lost. So put differently, we can also define it as the algebraic sum of every current entering and leaving the node has to be null or has to be equal to 0. So the property of Kirchhoff's law is commonly called conservation of charge, as it is based on conservation of energy, wherein current existing plus current entering equals to 0, or in other terms we can say that existing current is equals to the current entering the node or the junction. Okay, so this is the Kirchhoff's current law. So for understanding it in a better way, um, let's see this diagram. So this is a diagram. So yeah, so this is basically the first law of Kirchhoff's, or the current Kirchhoff's current law. So this is the statement. This is the simple, you know, way of describing the law. That is, current entering the node will be equal to current leaving the node. So what is a node? So first thing comes to your mind, what is a node? So node is nothing but node is basically a point or a junction which segregates two or more, you know, two or more components, or mm, two or more, you know, components in a particular circuit. So here this is a junction, this is a node, sorry, this is a node. So here you can see the current that are entering this nodes are I1, I2 and I3. Then the currents that are leaving this node are I4 and I5. So currents in, currents out. So this is basically the current current law, or Kirchhoff's current law. So I can also write it as uh, uh, I1 plus I I I2 plus I3 I3 equals to I4 plus I5. Okay, so that's the general idea about the Kirchhoff's first law, that is the Kirchhoff's current law. Okay, further moving on. Yes, so this is one of the perfect example of complex electrical circuits. So in such cases there are two currents, that is the I1 and I2. So you can see how complex this circuit is. So in such cases we cannot calculate the value of current or even the value of resistance by just simply by, you know, using formulas, directly by using formulas. So in such cases, you know, um, use we have to use Kirchhoff's current law and to find the current, or Kirchhoff's laws to find out certain values of current or voltage, whatever. So you see, this is the node that I was talking about, N1 N2. So you can see it is separating two components, R1 R2 R3, you know, three components it is separating. So this is the current I1 I2. So yeah, to solve such type of complex electrical circuits, we use Kirchhoff's rules. And yeah, obviously this Kirchhoff's current law, that is the first law of Kirchhoff, is also based on nodal analysis. So we also use this law to like solve questions related to nodal analysis. Nodal analysis means like those circuits where there is the presence of nodes, that is the N1 N2 and so on. Okay, so we won't go in depth, but I'm just giving the general understanding. Further moving on, it is the Kirchhoff's second law, or Kirchhoff's voltage law, one of the famous laws. So according to Kirchhoff's voltage law, or so this law, it states that the voltage around a loop equals the sum of every voltage drop in the same loop for any closed network n equals 0. Put differently, the algebraic sum of, so in other words, the algebraic sum of every voltage in the loop has to be equal to 0, and this property of Kirchhoff's law is also called conservation of energy. So it is based on conservation of energy. The first law was based on conservation of charge. This is based on conservation of energy. Now see, so it simply says that the voltage around a loop equals the sum of the voltage drop in the same loop for any closed network n equals to 0. So for furthermore understanding, I'll refer this diagram. So you see, this is a loop, okay? So this is basically the law in simple words or in simple terms. See, this loop A B C D A. In this particular loop, you can see the voltage, that is the voltage between A and B, and between B and C, and B C and D, and D and A. See, BBA is equals to 0. Simply it means that the voltage inside this loop, the net voltage or the total voltage in this loop would be equal to 0. The sum of the voltage drops across the loop is equal to 0. So that is basically the second law, or the Kirchhoff's voltage law. Okay, now moving on, this is so, and also Kirchhoff's voltage law is based on mesh analysis, similar to that of the nodal analysis, which was based on Kirchhoff's current law. Similarly, the Kirchhoff's voltage law is based on mesh analysis. So mesh analysis, these are complex circuits. So here there are mesh currents like I1, I2, I2, I1, I2, I3, and this. So in this particular kind of circuits, we probably use a KVL to solve this kind of circuits, okay, to find out the values of voltages and current. Now procedure to solve the problem. So specifically talking about the Kirchhoff's voltage law, okay. So what the procedure or the methods to solve the problems are: the algebraic sum of voltages near a closed loop should be 0. Okay, this is already given by the statement. Okay, so draw the current line direction and label the direction, the voltage direction. Remember, the voltage on a voltage source is always positive to the negative. So once you take the current as positive from a certain direction in a loop, you will not change the sign of that particular voltage. So that is the define either a clockwise or anti-clockwise direction as voltage drop direction. Once the direction is defined, the same convention is used in every. Okay, this is the same thing that I told. The sign positive for the voltage in the current direction and negative otherwise. Okay, apply KVL. So these are the rules that is used while solving circuits using KVL. Moving on, advantages of Kirchhoff's law. So basically, in the first introductory part, I already discussed this thing, that what are the advantages of Kirchhoff's law. Basically, there are two major advantages, although there are other advantages too, but the two major advantages that I could point out is that the calculation of unknown currents and voltages is easy. Obviously, it will be very hard for us to directly calculate the values of unknown currents and voltages by simply using Ohm's law. It is really not possible. So by using this laws, it would become feasible for us to solve those kind of complex circuits. So that is the first advantage or benefit. And the second one is simplification. Analysis of complex closed loop circuits become manageable. So like, yeah, obviously the same one. So if there is this complex loop, we can like manage it and easily calculate those quantities. So that is the advantage of Kirchhoff's law. Now limitations of Kirchhoff's law. Obviously there are the limitations. So the limitation of Kirchhoff's law, both laws, is that it works under the assumption that there is no fluctuating magnetic field in the closed loop. Electric fields and EMF could be induced with causes the Kirchhoff's loop rule to break in presence of variable magnetic field. So yeah, obviously magnetic field should be constant, while we should assume that magnetic field should be constant in us. Well, like applying this Kirchhoff's voltage law. That is the limitations and applications. This law analyzes how the current and voltage source work in the electric circuit. This law is used to calculate the unknown values. Yes, again the same thing. Kirchhoff's law was the first law that helped the analysis and calculation of complex circuits become manageable. And yes, it is the same thing again. which I repeated earlier. The Wheatstone bridge is an essential application of Kirchhoff's law. It is also used in mesh and nodal analysis. Yeah, obviously Wheatstone bridge is also essential application of. So Wheatstone bridge also application of Kirchhoff's law. So it is using mesh and nodal analysis. So this is the thing. These are the applications. Further moving on. Now comes the conclusion. Okay, this what we can conclude from this is that Kirchhoff's law is a fundamental electric law that helps solve and analyze the electric circuit quickly. Calculating the unknown current and voltage in an electric circuit becomes easier. Kirchhoff's first law is based on the conservation of charge. Kirchhoff's second law is based on the energy conservation. And Gottschalk Robert Kirchhoff described it in 1845. So these are the things that we already discussed in our PPT so far. So this is the conclusion here. With this, I come to conclude my PPT presentation of Kirchhoff's law. So yeah, this is my presentation, and thank you for watching. And yeah.